There are several options for setting up an outdoor transfer switch for house and garage powered by a generator, given a 200 amps meter pedestal with two 100 amps breakers. One option is to install a single 200 amps outdoor transfer switch directly to the meter pedestal. Connect both 100 amps breakers to the transfer switch input and connect the generator input to the transfer switch. Another option involves a double outdoor transfer switch setup. Option 1 is to install a 100 amps outdoor transfer switch for the house and another 100 amps transfer switch for the garage. Share the generator input between the two transfer switches using a sub-panel or disconnect switch. Option 2 is to install a 200 amps outdoor transfer switch as the main and a smaller transfer switch, for example 50 amps or 100 amps, for the garage. Connect the main transfer switch input to the meter pedestal and the sub-transfer switch input to the main transfer switch. Several guidelines are important for selection. Firstly, ensure the transfer switch amperage rating matches or exceeds the load requirements of the house and garage. Secondly, use a transfer switch that is compatible with the generator's voltage and amperage output. Thirdly, consider the location of the transfer switch for ease of access and weatherproofing. Fourthly, install a disconnect switch or interlock device to prevent accidental backfeeding of power to the utility grid. The use of a double transfer switch setup is feasible, but it may require additional wiring and equipment. Double transfer switches allow for independent control of power to the house and garage while using a single generator. All electrical work should be performed by a licensed electrician. Check local building codes and utility regulations before proceeding with any installation. Choosing the right setup depends on several factors, including the load requirements of the house and garage, the generator's capacity, and specific preferences for control and flexibility. A single transfer switch offers a simpler installation, while a double transfer switch provides more granular control over which circuits are powered by the generator. Let's delve into each option in more detail. The single transfer switch is the most straightforward approach. A 200 amps transfer switch will handle the entire load from the meter pedestal, allowing you to power all circuits in both the house and garage up to the 200 amps capacity. This option requires careful load management to avoid overloading the generator. With a double transfer switch configuration, option 1, using two 100 amps transfer switches, one for the house and one for the garage, offers the advantage of isolating circuits. This allows you to manage the load more effectively. If the generator has limited capacity, you can choose to power only essential circuits in either the house or the garage. This setup requires a means of sharing the generator input, typically a sub-panel or a disconnect switch. The sub-panel acts as a distribution point, splitting the generator's output between the two transfer switches. A disconnect switch provides a manual method of selecting which transfer switch receives power. With a double transfer switch configuration, option 2 involves a 200 amps main transfer switch and a smaller sub-transfer switch for the garage. This setup provides a balance between whole house coverage and selective control. The 200 amps main transfer switch powers the house, while the smaller transfer switch allows you to power specific circuits in the garage, such as lighting or tools. This configuration can be useful if the garage has lower power requirements than the house. Selecting the appropriate amperage rating for the transfer switch is crucial. The transfer switch must be rated to handle the maximum current that will flow through it. For a single transfer switch connected to a 200 amps meter pedestal, a 200 amps transfer switch is generally required. For double transfer switches, the individual ratings should be chosen based on the expected load of the circuits they will be powering. Compatibility with the generator's voltage and amperage output is another critical consideration. The transfer switch must be designed to work with the generator's voltage, typically 120 volts or 240 volts. The transfer switch's amperage rating must also be sufficient to handle the generator's maximum output current. The location of the transfer switch should be chosen for ease of access and weatherproofing. The transfer switch should be mounted in a location that is easily accessible for operation and maintenance. It should also be protected from the elements such as rain, snow, and direct sunlight. Many outdoor rated transfer switches are available, designed to withstand harsh weather conditions. A disconnect switch or interlock device is essential to prevent accidental backfeeding of power to the utility grid. Backfeeding can be dangerous, as it can energize utility lines and pose a risk to utility workers. A disconnect switch provides a manual means of isolating the generator from the utility grid. An interlock device prevents the generator from being connected to the grid unless the main breaker is turned off. In addition to these considerations, it is essential to comply with all applicable electrical codes and regulations. Local building codes and utility regulations may specify requirements for transfer switch installations. All electrical work should be performed by a licensed electrician to ensure safety and compliance. Before undertaking any transfer switch installation, it is advisable to consult with a qualified electrician and obtain any necessary permits. A professional electrician can assess the specific requirements of the installation and ensure that it is performed safely and correctly. The electrician can also advise on the selection of appropriate equipment and ensure that the installation complies with all applicable codes and regulations. Let's explore some additional considerations that might influence the choice of transfer switch setup. Firstly, consider the types of loads that will be powered by the generator. If the house and garage primarily use resistive loads, such as lighting and heating, a standard transfer switch will suffice. However, if there are significant inductive loads, such as motors or compressors, a transfer switch with a higher inrush current rating may be necessary. Inductive loads draw a large amount of current when they start up, and a transfer switch that is not rated for this inrush current may trip or fail. Secondly, think about the frequency of generator use. If the generator is only used occasionally during power outages, a manual transfer switch may be sufficient. However, if the generator is used more frequently, an automatic transfer switch may be a better option. Automatic transfer switches automatically switch to generator power when a power outage occurs, and they automatically switch back to utility power when the power is restored. This can be particularly useful in situations where it is important to maintain power without interruption, such as for medical equipment or security systems. Thirdly, assess the noise level of the generator. Portable generators can be quite noisy, and it is important to consider the impact of noise on neighbors and the surrounding environment. If noise is a concern, consider choosing a generator with a low noise rating or installing the generator in a location where the noise will be minimized. Fourthly, factor in the fuel source for the generator. Generators can be powered by gasoline, propane, or natural gas. Each fuel source has its own advantages and disadvantages. Gasoline is readily available, but it can be expensive and requires careful storage. Propane is cleaner burning than gasoline and can be stored for longer periods, but it requires a propane tank. Natural gas is the most convenient fuel source as it is supplied directly from the utility, but it may not be available in all locations. The choice of fuel source will depend on factors such as availability, cost, and environmental concerns. Fifthly, determine the maintenance requirements of the generator and transfer switch. Generators require regular maintenance, such as oil changes, filter replacements, and spark plug replacements. Transfer switches also require occasional maintenance, such as cleaning and inspection of contacts. It is important to factor in the cost and effort associated with maintenance when choosing a generator and transfer switch. Finally, consider the warranty coverage for the generator and transfer switch. Most generators and transfer switches come with a warranty that covers defects in materials and workmanship. It is important to read the warranty carefully and understand the terms and conditions. A longer warranty period can provide peace of mind and protect against unexpected repair costs. In summary, setting up an outdoor transfer switch for a house and garage requires careful planning and consideration of various factors. By evaluating the load requirements, generator compatibility, location safety measures, and other relevant considerations, it is possible to choose the right setup and ensure safe and reliable power supply during outages. Remember to always consult with a licensed electrician and comply with all applicable codes and regulations.